Okay, so this is a new section, and this is what we call probability distributions. And this one basically is more about where data comes from, how is data created, right? So we are going to define a probability distribution function, and the way that I'm going to go ahead and address it is as PDF. So I'm going to continually say PDF of this. I don't mean the paper, right? I just mean probability density function. So basically what this is just a tool that helps us by keeping track of outcomes of an experiment and their probabilities. So the way that we usually do this is given to us in a table, a graph, or a formula. So we need to keep in mind that everything needs to add up to 1. So for example, I gave 3 different examples here, right? So if we look here, here's a table, right? So here's a table. So basically what we want to make sure is that all the probabilities add up to 1. And as you can tell, here we got 0.3 plus 0.7, which actually gives us 1, right? So these are our outcomes. So this could have been easily maybe heads was 0, tails was 1, and it was an unfair coin, right? So it's just basically a table. You kind of set the rules. The first one's going to be your outcomes, right? And your other one's going to be your probability, right? Then we can also have a graph, right? So here's a graph, right? And what we want instead, and this is something that we're going to talk about next week, when we talk about a graph, we're actually talking about area, right? So we want to make sure that the area in this case is equal to 1. So as you can tell, this is just a triangle. How do we find the area of a triangle? Well, if you forgot, it's area equals 1/2 base times height. So the base in this case, right, is from 0 to 2. The distance between 0 and 2 is just 2. So the base of this triangle is 2. And then we want to make sure what is the height of this triangle. And the height in this case is equal to 1, right? So the distance from the tip of the triangle to the base, right, is just equal to 1, right? So then notice that this cancels out. We got a 1 times 1, which gives us 1. So the area is 1. So this is also a probability distribution, right? Now, we can also give you a formula. Now, we're really not going to work with formulas as much, but here's an example, right? Probability of x equals 2x, right? P of x equals 2x. 2x. And this is saying that x can only equal 0 and 1/2. So remember, we have to make sure that all the probabilities add up to 1. So I have to do it for each of the outcomes, right? So probability of x equaling 0 plus the probability of x equaling 1/2 has to equal to 1, right? That's just basically what this is saying. So I plug in 0, right? 2 times 0. I plug in 1/2, 2 times 1/2. Does this equal to 1? Well, let's see. This goes away. Half of 2 is just equal to 1. Indeed, it's a probability distribution, okay? So these are just 3 different examples of probability distributions that exist. However, the ones that we're really going to be working with right now are tables, because tables are super important, super easy to go ahead and work with, right? So that's what we're going to start off with, okay? Later on, we'll do graphs and formulas. So I noticed that I wrote the letter X here, right? Now, X is what we're going to define as a random variable. And this random variable, right, is a variable that is determined by chance, right? So it's not just a regular variable where we solve an equation and then we get x equals 3, right? It is a variable, but it can have different outcomes, and the outcomes depend on, well, how likely is it to occur? So there's 2 different types of random variables. So I'm going to write random variables here. So there's 2 different types. The first type is continuous. So we can have continuous random variables, or we can also have discrete random variables, right? So it really depends. So continuous random variables, right, can take on any numbers. These can include decimals, right? It can also include whole numbers, right? Fractions, right? Anything that you can possibly think of, right? Whereas discrete random variables, right, these numbers are just whole numbers or integers. So there are no fractions, there are no decimals in discrete, right? All we can just think of is like 0, 1, 2, -3, 4, 100, whatever we can think of that's whole. Whereas continuous, you can think of a 1/2, 1/4, 0.137. So they also include the whole numbers, but continuous random variables can also include decimals. Okay, so those are the two different types, okay, of random variables. So here's an example. Okay, so determine if the following are discrete or continuous random variables. Okay, so the number of siblings. Would a number of siblings be discrete or would it be continuous? Now, the way that I think about it is that if I can go ahead and include decimals and fractions, then I know that it's going to be continuous. But if I know that it's only going to be whole quantities, then it has to be discrete. So if we think of number of siblings, can I have half a sibling or a third of a sibling or 1.5 siblings or 1.7 siblings? Not really, right? So in this case, this would be a discrete random variable. So it's discrete. Okay. The number of people in a passing car. Well, what are we modeling? We're modeling still number of people, right? So this is still going to be discrete, right? You can't have a third of a person, right? The weight of a submarine. Well, weight can be 1,000 pounds, 2,000 pounds, but it can also be 1,000.5 pounds, right? So you can include decimals in this case. So in this case, the weight is going to be continuous. Okay. And then the amount of time for the next bus to appear, well, we're looking at time in this case, and time itself is continuous, so it would make sense for it to be continuous. Now, many of you guys may think it's discrete, and it is discrete in some sense, but we need to make sure that if I know that I can add decimals and if I can add fractions here, then I know in this case that I'm going to be dealing with a continuous random variable. Okay, so in the next video, I'm going to show you guys how to create probability distributions. I just wanted to go ahead and set the framework of what probability distributions are and random variables.